factoring and more factoring. We are continuing along with factoring today. I'm sure you are probably tired of it at this point, but we are just going to keep taking that deeper dive look at factoring and how we can put some of the different types of factoring together. So for example, today we're going to look at something like 3x squared minus 75. Now, we've already talked in class now about that idea that maybe the number of terms can help us determine what type of factoring we want to lean towards. And so we might say, okay, this is 2 terms and this is subtraction, but these are not both special cases. So this is not, or sorry, these are not both perfect squares. So this is not something we can factor as a special case. Which then leaves us with the last idea of factoring out a GCF. Now, just like we said in our last e-learning video, looking for that GCF first can really help us get smaller numbers. So our first step is still going to be to look for that GCF. Even if it was a special case to start with, if we can factor out a GCF and get those numbers smaller, that's always going to help us. So can we think of a number that goes into 3 that will also go into 75? Hopefully we say yes, we can divide these both by 3. Okay, so we're going to factor out that GCF, which will leave us with an x squared minus 25. Then, just like we did in our last video notes, we're now going to focus inside the parentheses. So now when I focus inside the parentheses, I'm going to say, okay, it's 2 terms. It is subtraction, and they are both perfect squares, right? What number times itself gives us 25? Well, that's 5. And if we have half of the exponent, that's an x, okay? So now when I look inside those parentheses, now I can factor a special case. And again, I'm kind of writing down these steps over here just of what I'm doing, but that doesn't necessarily mean that that's what happens every time, right? You kind of just have to look at those pieces and see what happens. So when we get this x and we get this 5 and we factor a special case, what does this x squared minus 25 factor into? Right, 2 binomials where they look the same, but one gets addition and one gets subtraction. Now in our last video notes, we said we can't forget this GCF in front, so we're gonna bring down this 3, and we'll get a final factored answer of a 3 times an x plus 5 times an x minus 5. Okay, so let's look at another one. Let's say we have 4y squared minus 100. So this is one of those problems that I was just talking about, where when we look at this, we really could look at this and say, okay, yeah, this is a special case to start with. But if we look at this, these numbers are larger than if we were to factor out a GCF first. So trying to factor out that GCF first is going to give us those smaller numbers to work with. So what number will go into 4 that will also go into 100? So we can pull a 4 out here, which will leave us with a 4 times a y squared minus 25. Now, very similar to the one we just factored up here, right? So we know that this should factor into a y plus 5 and a y minus 5. Now for our final answer, we have to make sure to include all of the factors. So what's our final answer going to be? Right, we just need to bring that 4 down in front. So we need a 4 with a y plus 5 and a y minus 5. And just like we've been saying all unit, if those 2 binomials were flip-flopped, we'd be fine. Now, I just want to show you what happens if you miss that GCF first. Because again, just like before, it doesn't mean that it's impossible. It just means that it's a little bit of extra work. So if we look at this 4y squared minus 100 first, and we think, okay, this is a perfect square because this is 2y times 2y, and this is 10 times 10, right? This will then go into 2 binomials where I'll have a 2y plus 10 and I'll have a 2y minus 10. The problem is that this 2y plus 10 then has a GCF. So that has a GCF of 2. So that becomes a y plus 5. But this one over here also has a GCF of 2. And that becomes a y minus 10. Now, be careful because this isn't factoring by grouping, right? I have 2 times y plus 5 times 2 times y minus 10. The order of multiplication doesn't matter, so those 2's can be multiplied together. So 2 times 2 is 4. Sorry, guys, this should be a 5. I copied it down wrong. I just didn't divide. Okay, 2 times 2 gives us a 4, which gives us the y plus 5 and the y minus 5. So we'd get the same answer. We just have to factor that GCF out twice, which just becomes a pain in the butt. So catching that GCF first is really helpful. Okay, so next one here. Let's say we are given w to the 5th minus 256w. Okay, so definitely not a special case here. So what's our GCF going to be? Our GCF is w, so if we pull that out, 5 minus 1 gives us 4. And then the other w's cancel out, so I have w to the 4th minus 256. Okay, so now we're going to focus inside the parentheses. So I'm focusing here, and I'm checking to see if that's a special case. If you're not sure about the 256, you can do second x squared 256. Okay, that gives us a 16. We can take half of that exponent, so this is a special case. Okay, so what is w to the 4th minus 256 going to factor into? This will give us a w squared plus 16 and a w squared minus 16. Okay, we still need to include that GCF in front. Now here's where you're all gonna be like, oh, Mrs. McKinney, we are not done yet. Because if we look over here on the right, that's a special case too, right? This is not a special case because it has an addition sign, but this one here is because it's 2 terms, it's subtraction, and these are both perfect squares. So 4 times 4 gives us 16. Half of that exponent is a w. Okay, so that means that our w squared minus 16 is going to factor into what? We should have a w plus 4 and a w minus 4. Now, we need to include the other factors. So what is our final answer going to be for this one? We need to include all of this other stuff in it so that w gets included and that w squared plus 16. Okay, now you might be tempted to say, well, what about this w minus 4, right? It's not a w squared, so that cannot be factored. So this is our final answer. And at this point is usually when my students are like, oh dear, this could get pretty long pretty quick. And you're exactly right. We can run into problems that take a significant amount of factoring, which is why I've really been stressing the fact that you need to know how to factor. Okay, because as they get longer, you just need to be able to look at that w squared minus 16 and just recognize that it's a special case because you've done enough of them. Okay, so we're gonna look at one more problem here. Let's say we are given 9a squared plus 36. Okay, so what have I said every single time is gonna be a good idea to look for first? We wanna look for a GCF. Okay, so what is our GCF here? What goes into 9 that will also go into 36? Right, we can pull out a 9. Okay, so if we pull that 9 out, that will leave us with an a squared plus 4. Then we're gonna look here inside the parentheses. A squared plus 4, is that a special case? Right, we better be saying no because this is an addition sign. Okay, and it's important to remember all the factoring that we've done to prepare for the test this week doesn't just go away. And it's totally fine to have a problem where we can only factor out a GCF and that be our final answer.